The localhost lab, and today we are continuing the system design pattern series, and in today's video we'll see creational design patterns. So if you have not watched my video on introduction to system design pattern, I will highly recommend you to go and watch it before you continue with this video. So in that introduction to system design pattern, we saw there are three categories of system design. The first one is creational, then structural, and behavioral. So here we'll see the creational design patterns. Now under creational design patterns, there are a lot of patterns which we'll see one by one. So a quick brush up. So what are creational design patterns? So these patterns, they mainly deal with object creation mechanisms. So how the objects are being created. The idea or the goal is to create these objects in such a way that they are very flexible, reusable, and they are created in a very controlled manner by the developer. So what are the different types of creational patterns? Singleton, factory, abstract factory, builder, and prototype. So in this video we are only focused on singleton pattern. We'll see what is singleton pattern, what are the real life use cases, and we'll also see different types of singleton, how we can achieve singleton design patterns. There are different types followed by Java code examples. So let's start with singleton pattern. So a quick introduction. So as the name suggests, singleton, single, one. So this pattern ensures that only one instance of a class exists, and it provides a global access point to that instance. So there is only one instance of a particular class, and this pattern also ensures that it provides a global access point for that particular instance. Every other member who wants to access this instance, there is only one global access point. Now when to use this pattern? For what problem statement we should use this singleton pattern? So we will only use singleton when we only need one instance, when there is a requirement for only one instance should exist, when there is some sort of shared resource management is required for global configuration or centralized coordination, because creating objects are very expensive, and there are few use cases where we don't want to create objects again and again. We can reuse a single instance. The whole application can use a single instance. So for such problem statements, we should use singleton pattern. So what are the common use cases, industry examples? Let's take some common examples that you must have at least heard of, or even worked on. Logging frameworks. So for logging, we don't want to create objects again and again, so we can use singleton pattern here. And also for configuration classes. So for any application, the configuration is global, right? Every member or every class, they refer to the same configuration property file, right? And also caching. So the whole application uses cache, a shared in-memory cache. For database connection managers, so this singleton design pattern, it's very commonly used for database connection managers, and also for Kafka producer manager. So shared producer instance this is to improve the performance. So like I mentioned, what are the benefits of singleton pattern? Controlled access to object. It saves memory. There is a global access point, so there is only one instance, and there should be a global access point for that instance. And we will not create objects that we don't require. Unnecessary object creation is avoided if we use this pattern. And this pattern is it's very beneficial if there is a shared resource kind of scenario. So what are the characteristics of singleton pattern? So whenever you want to use singleton pattern, just remember this: make the class constructor as private, create a static instance variable and a static access method. So there is only going to be a single object lifecycle, and by doing this we are controlling the instantiation of that particular class. This will become more clear to you when we jump into the actual code. Now before we proceed further, let's understand this concept called lazy loading. This is going to be beneficial for the types of singleton that we'll discuss in the further slides. So what is lazy loading? It is a design technique where an object or resource is created only when it is actually needed. We will not create any unnecessary object which we are not going to use at that moment. We are delaying the object creation until there is a requirement for it. Delay object creation until its first use. So this is something called as lazy loading. So why we have such a mechanism? Why are we using lazy loading? So see, whenever we create an object, it will consume memory and it will take time. And also open database and these are all expensive tasks. And why should we create an object which we are not going to use at this particular moment? We are unnecessarily loading the resources, unnecessarily consuming the memory. All these things will take time. So by using lazy loading, we are improving the performance, the memory usage, and how we are utilizing the resource altogether. Now I hope this is very much clear to you, because this is like one of the core points of singleton design pattern. Now for singleton pattern implementation, there are different types: eager, initialization, lazy, thread safe, double checked logging, locking singleton, bill, puke singleton, and static block. Now this is I've created a table, and here, so there are different types for singleton implementation. Now this table gives you an idea which type is more preferred over another, and the highly recommended type is bill puke. The other, you can, for sake of interview, you should know what are the different types. But if you are actually using this pattern, ensure that you use this. This is highly recommended. So now this is done. Now let's see code example. So let's first see lazy initialization singleton. So here you see, like I have mentioned the characteristics. So here I have made the constructor as private. We are controlling the instantiation of this particular class. So what we have done, we have initialized a static instance variable of this class, and we are, so first let's see the eager initialization, then we'll come to lazy. So here what we have done is, we have created a private constructor, we have created a static instance variable, and we are creating its object, see here. And then we have this static method using which we can get the instance. Okay, this is returning instance. Now this is obviously thread safe, and it's a very simple implementation. And here you see, even if this object is not required, it will be created. There is no lazy loading concept here. So will this affect performance? Yes, it will. So now we'll go towards improvement. which is lazy initialization singleton. So here we are not initializing the instance altogether. We are putting a condition: if instance is equal to then only create its object, and then we are returning the instance. Okay, whenever someone calls this, the condition will be checked. If it's true, we are creating this. So when first time, this condition is always going to be true, so we'll create the object. Now tell me something, is it thread safe? No. So two different threads can call this. Thread 1 sees ki instance is null and it will create an object. Another thread comes at the same time, it sees instance as null and it will again create an object. This is not what we want to achieve. So this is not thread safe. So another approach is thread safe singleton. We'll use synchronized keyword. So this is thread safe, but since we are using synchronization, there is an overhead. So whenever there is a call to this method, singleton.getInstance, it will acquire a lock. Even if the object is already created, every thread will acquire a lock. So there is a performance overhead. And again, we have created a static, private constructor. All these are valid. All the characteristics are valid for all the types. Here we are using synchronized. So we have a performance overhead, right? Can we make this more? Can we optimize this further? Let's see. Then we have the next type of singleton pattern implementation. Here we are going to use volatile. So here, if instance is null, then we have a synchronized block. If again this instance is null, we are creating an object. So this is thread safe, and whatever approach for this, when we are using synchronized, this is an further optimization. Now we are using volatile, so every thread will immediately see the fresh value and not stale value. So when you use this keyword, it tells JVM to always read this variable value from the main memory and not from a thread's local cache. So this has a better performance compared to thread safe singleton. And the next is Bill Pugh singleton. So here we are using an inner class. Again, the constructor is private and we have a static method to get the instance, but here we don't. Here inside the inner class, now we are creating the static instance variable. So since this initialization of this instance variable is inside child class, so this will be lazily initialized, and obviously this is going to be thread safe. And obviously we are not using synchronization, so there is no overhead, and this is the most recommended approach. Then the last is static block. So again, we have created a static instance variable, and we have a private constructor, and we have a static method to get the instance, and here inside the static block we are initializing. So this is what singleton design pattern is, and usually they in interviews they'll ask you to answer in what scenarios you should use singleton and what are the different types and its implementation. I hope this video is clear. This singleton design pattern is clear to all of you. And if in further videos, in the next video, I'll discuss the factory pattern. So stay tuned for it. Thank you for watching and subscribe for more such videos.